Okay, we're in the middle of this example and I've done FOIL to find the product. We can take I squared and turn it into a -1. So if this becomes -1, this whole term becomes positive, and we can see that these two terms will cancel out. And we can add the like terms 4i and 12i, and we get 16i. The next part asks us to write each number in trig form. All right, well, we want to write each number in trig form. So let's take z1 and think about graphing it. We've got -1 plus root 3i. So this, we can think about constructing a triangle, and this would be -1, and this is root 3. And if you remember the sides of the 30, 60, 90 triangle, we can see right away that the angle here is 2 pi over 3. Another way to do that is to think about the tangent of the angle being the opposite over adjacent. Opposite over adjacent is the same as b over a, using the notation with the standard form of a complex number. And in this case, the tangent of what angle is root 3 over -1. Well, the angle for if it was positive root 3 would be pi over 3, so you have to think about the second quadrant. The corresponding reference angle would give us 2 pi over 3. The other piece of information we need to find is the radius. And remember that the radius is the same as the square root of a squared plus b squared. So in this case, the radius is the square root of -1 squared plus root 3 squared. So this would be 1 plus 3, square root of 4 is 2. And I should have labeled, since we have two different complex numbers, I should have labeled this as theta1 and this as radius1. We're going to go through the same process with the other complex number, z2. I like to start by graphing. So positive 4 root 3 and -4i. So 4 root 3 would be out a little bit further. 4 root 3 and -4. We can think about plotting that complex number here. Again, we can figure out the angle by thinking about b over a, or -4 over 4 root 3, which would become -1 over root 3, or root 3 over 3. So the tangent of what angle is root 3 over 3. We can also see by the illustration that that angle, because of the quadrant that it's in, is going to be the angle 11 pi over 6. This is our second angle, so I'm going to call it theta2. We also need to find the second radius, and we can do that by doing the square root of a squared plus b squared. So this would be 16 times 3 plus 16. If we simplify all that, we get 64, and the square root of 64 is 8. So we can write z1 in trig form by writing r1 cis theta1, which is 2 pi over